Dear students, in this video I shall be explaining the clamping circuit experiment. So in this clamping means adding some DC, means we are clamping the input waveform to a positive side or to the negative side. So if you apply some if you add some DC, the total waveform will be shifted either upwards or downwards. Means shifted means we are adding some DC here, so DC gets added here, then the waveform will be shifted either upwards or downwards. If it shifts upwards like this, right, so this is the input waveform. We can take any input waveform. Here we are showing that some +4 to -4, 8 volts peak to peak, or you can take 2 volts peak to peak or 4 volts peak to peak, whatever waveform you want. So this is the input waveform. When you see the reference line here, this is the reference line and it is equally divided on either side of the reference line. When you clamp it, it shifts upward, means above the reference line. You can see this is the upward shifting. I am just showing. Now we shall do the experiment afterwards. This is the upward shifting, so the total waveform shifts upward. This is positive clamping, and you can see the negative clamping. The total waveform shifts by some voltage to the downside. So this is negative clamping, and how it is achieved we shall see. So this is the clamping negative clamper circuit. This is the negative clamper circuit. Now we shall connect this negative clamper circuit. So this is the output of it. You can see the input here. So it is equally divided on either side of the reference line. Now it shifts downwards. So only some small part of the positive half cycle remains on upper side of this reference line, and the total waveform will be shifted down. So this is negative clamper. So negative bias is added. So total waveform will be shifted down. Now we shall see this one by connecting the components. So we shall take one capacitor here, 47 microfarads capacitor, and connect it like this, and the resistor and the diode should be connected in parallel. So take a resistor, 33K resistor, and connect it to the negative end of the capacitor like this, and choose one node here also, and across this resistor diode should be connected. So positive side is connected to this node like this, and negative side connected to this node. So this completes our 3 component circuit: capacitor, diode and the resistor. Right, now we have to apply the input waveform. So first we shall generate the input waveform. So we keep on this function generator, choose the function as the sine wave, and keep the frequency at 1 kHz, and the input can be taken. Now for example I am taking 2 volts peak to peak. So just connect it to the, verify whether it is 2 volts peak to peak or not, or 4 volts, whatever you want you can take. So connect it just to display the output coming from the function generator on the CRO. You can see, right. So in the channel 1, connect a probe and connect it to the probe which is connected to the function generator, and verify the, or display the waveform and verify the amplitude. So what is this amplitude? I am choosing a 2 volts per division option on this voltage knob. Now it should be 8 volts peak to peak, right. The input waveform should be 8 volts peak to peak. So 2 into 4 divisions it has to occupy. I am adjusting the voltage on the function generator. So in the function generator, adjust the amplitude knob and adjust it so that it occupies from peak to peak 4 divisions, 4 main divisions. So this is 4 main divisions it is occupying. So 4 main divisions into 2, that will give you the 8 volts peak to peak input voltage. Now you apply this input voltage to the circuit. Okay, so this is this is input point of the circuit, one positive end of the positive terminal of the capacitor, and this is the point where diode and resistor both meet, that is other end of the input or other terminal of the input. So I have applied the input. For observing the output, put a probe on the channel 2 of the CRO and take the output across the parallel combination of diode and resistor. So this is the higher potential or red one, right? So connect it to the probe and put it to the upper potential point of the output, that is this point, right? And this is ground, that is lower potential. We have already connected here, just connect it to the black terminal and you can see the output. Yeah, you can see the shift here, right? So it is shifted. So for observing the output, first you have to adjust the waveforms here. So on the channel 1 where the input is there, put it into the ground option. You can see a line here. So this is the line corresponding to the channel 1. So coincide it with the middle line of the screen, right? Ground, put it in the ground. You can obtain a line here, DC line, and coincide with the middle line of the screen, then put it into the AC option. So that means the input is equally spread on both sides. You can see from the middle line it is occupying 2 main divisions on upper side and 2 main divisions on the lower side. It is equally spread. Now the total waveform will be shifted down in the output. Now for observing the output, you have to choose the option here to DC, because you have some DC is getting added due to the clamping here. So you have to put this into the DC option. Okay. See, now you have to choose the DC option. I am choosing the DC option for the output. So input should be in AC and output should be in DC. So first you just coincide with this one also, with the middle line. So input is already coincided with the middle line, and if you put into the AC option, you can see the input. Now output also put into the put on the middle line. This reference line should be coincided with the middle line of the screen, and then put it to the DC option. Now you can see the total waveform is shifted downwards. Now let me show you once again. This is the output. Now this is the input. You can see the upper one is the input, the lower one is the output. So total waveform is shifted downward by some voltage, and what is that voltage? You can measure from this reference line. So this is the reference line, the middle line, you can see. So from middle line, how much voltage you are having? So it is occupying some 0.3 main divisions. So out of the full main divisions, it is occupying 0.3 main divisions into 2, that is 0.6 volts. Above the middle line, it is having only 0.6 volts, and the remaining 8 volts is the peak to peak. So peak to peak 8 minus 0.6, that is 7.2 volts will be below the reference line. So it is shifted by 7.2 volts downwards. That is the negative clamper. You can see here, this is V gamma. So above the reference line only V gamma, that is 0.6 you need to have, right? And the remaining, so from peak to peak it is 8 volts, the remaining 7.2 volts will be below the reference line or this zero line. Now the exactly what we are getting is this is the output spread evenly on both sides of the reference line. Now this is the input, right? So the output on upper side of the reference line you have only 0.6 volts, which is nothing but V gamma, and below the reference line you have got minus of 8 minus V gamma. So 8 minus V gamma is 0.6, so 7.2 volts you are getting. So you can see you are having a 7.2 volts. So it is completely shifted down by 7.2 volts, right? So this is the negative clamper. By interchanging the diode and the capacitance, you can get the positive clamper, so that the total waveform will be shifted upwards. Okay. Now we shall see one biased clamper. Now if you have seen the negative clamper where the total waveform is shifted downwards, in the biased clamper I will show you which shifts upwards. So this one, positively biased positive clamper I am going to connect. So let me connect this one according to the circuit. Positively biased positive clamper. Now you have to choose the take the 2 volts and apply to the input. So this is the 2 volts. Now using the multimeter, select 2 volts. Just as in case of the clipping circuits, so you can use this knob, variable knob, and choose the voltage here. So I am choosing 2 volts here as bias. So apply this 2 volts bias to the circuit. Now let me connect the circuit. So according to this circuit, positively biased positive clamper, I am connecting the this capacitor here, and diode and resistor are connected in parallel, and this point where diode and one terminal of diode and one terminal of resistor is connected, apply plus the positive terminal of the battery, that is higher potential side of the supply. So right, I am taking the higher potential side and putting here, and the lower potential is applied to another point which is also one terminal of the input. So I am putting here, right. Now the input is applied between this negative terminal of the capacitor and this ground terminal. Okay, you can see. So positive higher potential of the input is applied between capacitor, and the lower potential, this black one, is applied to the ground here, this one. Now output is taken between this point and this ground point. Now this is input is seen on the CRO screen. So input adjusted to middle one, like this. So it coincides with the middle line, and then put it into the AC. So AC means it is equally spread on both sides of the middle line or the reference line. 4 volts up and 4 volts down. Now we shall see what is the output. So take this probe and give it to the channel 2 and connect it. So the higher potential end of the output is connected to this point, that is this one, where both capacitor positive end, diode and resistor both are meeting at this node. You will connect the higher potential end of the output here, and lower potential, it is ground, connected to this one. Already it is there. Now we shall observe the waveform. It is already shifted, so just adjust it to the ground and coincide it with here, right, to the middle line. Now put it into the DC. So just observe once again, just put it in the ground option, you will get a line. So that line you coincide with the middle line. This is the reference line. Now put it into the DC option. Output should be always in the DC for clamping circuits. You can see the total output. It is shifted upwards. This is the input, equally spread on both sides of the reference line. Now this is shifted upwards by some voltage. By what voltage it is shifted, we have to observe now. So from here to here it has been shifted. So what is the voltage? You can observe from the reference line. From the reference line, what is this voltage? We shall see now. Okay. So this is from the reference line. This is 1, 2, 3, means 7. 0.7 main divisions into 2, that is 1.4 volts. So from the reference line, it is up by 1.4 volts. and from 1.4 the total waveform, right? It is 8 volts peak to peak, 1.4 to 8 part plus 8, so 9.4 from the reference line. The positive peak, of course it is not visible here, so positive peak is 9.4 volts on upper side. So total waveform is shifted by 4 volts plus 1.4 volts. By 5.4 volts it has been shifted, right? Now you can see here in the output it is above the reference line. Output is above, completely the waveform is above the reference line. As you can see, this is the reference line middle. The total waveform is above the reference line, right? So by how much amount it is above the reference line? 2 minus V gamma. V gamma is around 6, so 2 minus V gamma is 1.4 volts. Now as we can see, 0.7 into 2, that is 1.4 volts above the reference line is this negative peak, and positive peak plus 8 volts, because peak to peak is 8 volts waveform we are taking. So it is 9.4 volts, or else you can choose the ground point lower, right? So if you choose the ground point here, if you choose this one as the reference line, you can observe the total waveform also, because it is not visible. Yeah, put it in the AC, right? You can see now I have chosen this one as the reference line so that you can see the this one also. So from this reference line 1 2 3 4 around 7, 4.7 or 8 maybe, right? So 4.7 into 2, that is 9.4. So 9.4 is the this positive peak. So what is this? Here you can see 8 plus 2, 10 minus V gamma 0.6. So 10 minus 0.6, 9.4. So that is what you can observe here. From the reference line it is above 9.4 volts. Okay, so this is biased clipper, and we have some more clamper circuits here. This is one positively biased negative clipper, and this one, by properly connecting the circuit and giving the input, you can observe the proper outputs also here. Thank you.